method is a method that is, again, in my opinion, it's an easier process, but it's harder to understand, like, how to use it. But so if you can use it this way, it winds up being far less work. Right? And that is by using factoring. Okay? So if you choose to solve these by factoring, what you're going to do is you're going to rewrite everything as a rational power. So here we would get x plus 4 to the what power? 1/2 minus 2x times x plus 4. Now what power is going to move a square root or identify a square root that's in the denominator? Negative 1/2, good. Okay, and that's all over x plus 4. So if you think of this in its rational power form, what you can now do is you can treat it as a factoring problem. You have two groups of factors separated by a minus. There's a common base between them. The base is x plus 4. And so you remove that common base. Anytime you factor out or remove a common factor, you always take out the smallest power. The smallest power is furthest to the left on a number line. So which one is further to the left, 1/2 or negative 1/2? Okay, so there's our common factor. Okay, as with all factoring, once we remove our common factors, whatever's left inside has to have the exact same form as the original. One group minus another group. Okay, so let's see what is left. Okay, factoring out is dividing, and when you divide exponents, what do you do with their powers? Subtract. So we're going to subtract a power of minus 1/2, which is equivalent to adding the opposite. And so what's left in this first group? X plus 4 to the what power? 1/2 plus 1/2, which is 1. Okay, so it's just the x plus 4. And then in the second group, we remove a power of negative 1/2, which is equivalent to adding the opposite. And so here, negative 1/2 plus 1/2 gets you a 0, so that entire factor is removed, and we're left with just the 2x. Okay? The x plus 4 stays in our denominator here. Okay? And so the final things to simplify this, any negative powers we can just move into the denominator. It becomes x plus 4 to the positive 1/2. And we can combine our like terms here. So an x and a minus 2x nets you negative x plus 4. Over in the denominator, we have a common base. So we can, when we multiply exponents with the same base, we add their powers. So x plus 4 to the first, or the equivalent 2/2. 1/2 plus 2/2 gives us our 3/2. And so we get our answer. And once again, we could write it in either form. You could take out your negative, hoping to cancel a factor if possible, and finding out that you can't here. Either way, you get your correct answer. Right? So in all the problems at the end of section 4.4, there's going to be a whole bunch of them. Some of them are even start as these rational powers and negative powers. If you're more comfortable working with the first method, or this complex fraction, just convert from rational power into fraction form. And then you can solve it this way. If you understand the factoring and can do that, just use this method.